All right, UALR, final exam review, question number 26 for college algebra class. We're asked to consider the following function with factors x minus 3 and x plus 2. Verify the given factors of f of x. If you divide a polynomial by a factor, your remainder is going to be 0. They have started a synthetic division for us. When we divide by x minus 3, we take the coefficients of the original function, 1, -7, 5, 31, and -30. Put them in a list here, and then the opposite of what you see in that linear factor we're trying to divide by, we put that in a box. Then we bring the first term down, multiply the first term by 3 on the outside, put the 3 here, and add this column to get -4. Then we multiply -4 times 3 to get -12. Then we add this column to get -7. We multiply -7 times the 3 to get -21 here. We add that column and get 10, multiply times the 3 and get 30. When we add this column, we get 0. The last number in the synthetic division is always a remainder. When the remainder is 0, it means that the factor that we divided by is actually a factor of the polynomial. So that means that this function can be written as x minus 3 times the 1 is going to be the coefficient of our x cubed term, because it's going to drop 1 from the original degree. So it's going to be 1x cubed minus 4x squared minus 7x plus 10. We can rewrite f of x factored like that. Then it tells us to do the same thing with x plus 2. We start the synthetic division, drop the 1 down, multiply by -2, put it here, add that column, get -9, times -2 makes 18, add this column to get 23, multiply that times -2 to get -46, add that column to get -15, multiply that times -2 to get +30, add that column, our remainder is 0. So x minus 3 and x plus 2 are factors. That's how you verify the factors. Now, the next one says find the remaining factors of f of x. To do that, if we know that x minus 3 is a factor and x plus 2 is a factor, it means we can write this polynomial as x minus 3 times x plus 2 times some other factor. Well, here we've already divided the original function f of x by x minus 3. If we divide this factor, the x cubic factor, by x plus 2, then we'll have a quadratic factor that we can find the other factors with. So I'm going to set up a synthetic division with this cubic, where the coefficients of this cubic function, or this cubic factor, and then over here I'm going to use the opposite of 2, and we're going to do another synthetic division. I'm going to bring the 1 down, multiply by -2, add this column, get -6, multiply by -2 and get +12, add this column to get 5, multiply that times -2 to get -10, and my remainder is 0. So this came from this cubic polynomial, which tells me I can write that as x plus 2, the factor I was dividing by, times x squared minus 6x plus 5. So the x minus 3 is still a factor. So this original f of x is still, there's now x minus 3 times x plus 2 times x squared minus 6x plus 5, which is a quadratic that we can factor, because we can find two numbers that add to make 5 and multiply to make -6. Those numbers are -1 and -5. If you multiply x times x, you get x squared. X times -5, you get -5x. -1 times x, you get -1x. And -5x plus -1x makes -6x. And if you multiply -1 times -5, you get +5. So that means that x minus 1 and x minus 5 are the remaining factors that we're looking for. It says to enter them as a comma-separated list. It says use your results to write the complete factorization of x. That's what we did here. But f of x is going to equal x minus 3 times x plus 2 times x minus 1 times x minus 5. And we know from what we did in class, when we have it written as factored form, we can set each factor equal to 0 and solve, which would make the real zeros positive 3, negative 2, 1, and 5. Whatever numbers we could plug into those factors to make them 0. We can confirm our results by using a graphing utility. Remember, that's a calculator. So I'm going to graph this in its factored form. We can do it either way, but since we have it written right here in factored form, I'm going to graph this in factored form. I'm also going to change the window to match what they have. They have the x's going from negative 10 to 10 and the y's going from negative, looks like about 170 to 170. Let's look, oh, we didn't graph this one. We didn't enter this. That's the function that was already in there. Let's graph this in factored form. So I have x minus 3 times x plus 2 times x minus 1 times x minus 5. Now we'll graph the right function. This does not look like this graph. Looks pretty much like this one, right? Let's check the others though. Yep, doesn't look like this one because this one only has one intercept on the left side of the y-axis. This one has 2. And doesn't look like that one. So it is this one here. And that's how you do problem number 26. Make sure that's all the parts. I think it is. Yep.